Hello, welcome to my second video lecture on Picat. In the first lecture, I gave two example programs in Picat. The first example simulates a finite automaton, and the second example evaluates an expression. The examples are quite intuitive. I hope you liked them and had no problem doing the exercises. In this video, I'm going to familiarize you with the basics of the Picat language, including the data types, operators, some of the basic built-ins, and language constructs. Let me start the Picat system first. Well, this is a REPL environment. Okay, basically the Picat system reads in a query, evaluates it, and prints the result, and then loop. Picat is a logic language. Every query must be a logic statement, which is either true or false. If the query is true, then the system may return an answer through the variables as the bindings. Picat is a dynamically typed language. That means you don't need to declare types of variables. A variable gets a type when it gets a value. A value in Picat is called a term. A term can be a variable, an atomic term, or a compound term. A variable name must begin with a capital letter or an underscore. So x is a variable, so it is true. It says true, x is a variable. All right, let's say we unify x and a, and then say x is a variable. And after x gets a value a, and then x is no longer a variable, so the query fails. It says no. And okay, this is also a variable. Yeah, okay, because it begins with an underscore. And this underscore by itself is also a variable. This is called an anonymous variable. So it is also a variable. And we can check if two variables are unifiable. Of course, two variables are always unifiable. So x, y, okay, this is successful. Okay. And we can also check if two variables are identical. So x equal y. Okay, these two variables are not identical because there are two distinct variables. So the query, okay, fails, and also the system gives a warning. Yeah, okay, because this test is superfluous, and because these two variables are distinct, and it always fails. And well, this underscore, okay, it is worth mention. This underscore, okay, two underscore, okay, is okay. This of course are unifiable, but two underscore, okay, if you test them, if they are identical, okay, the system says, all right, no. Okay, so each anonymous variable is a distinct variable. And a variable can be an attributed variable. That means we can attach attributes to a variable. And in particular, a variable can be a domain variable. In general, okay, a variable, a free variable, okay, can be unified with any term. And if it's a domain variable, then okay, it can be unified with only a value in its domain. So for example, in order to use domain variables, we need to import one of the constraint modules. Let's say import CP. And then can we say, okay, the domain is 1, 2, 3. All right, then we say it is a dvar. Okay, it's test if the variable is a domain variable. Okay, it says it is a domain variable, and we can okay, so x takes a value. What is x? Okay, we can use this built-in to find a value for x. All right, so then the system says x is 1. All right, you can ask for another answer. Okay, x is 2, x is 3, and then no more value. All right, you can also use this built-in solve. All right, this to label the variable with the value solve. Okay, so of course in this example there are no constraints. Okay, basically solve just enumerates the values in the domain. Okay. All right, now numbers. Okay, numbers are not that much in Picat, are not that much different from numbers in other languages. And numbers, well, some of the basic operators. All right, so you can use addition. Okay, so for example, x equals 1 plus 1. All right, so and this is some of the operators, built-in operators. So there's modulo, yeah, modulo. So x, say modulo 2, okay, and there's a remainder. Well, basically, okay, if the operands are non-negative, then these two operators are equivalent. And also, there's a power operator. Okay, power operator. And real numbers. Okay, x is 1.2. Real numbers 1.2 e exponent. Let's say 10. All right, exponent. And oh well, it is worth mentioning Picat supports big integers by default. Okay, so the operations you can never worry about overflows. Okay, so for example, x equals to the power of 100. Okay, so you get a big integer. And also the math module is pre-imported, so you don't need to import the math module in order to use math functions. Okay, so for example, x is sine and sine 2.0. Okay, so okay, so that means well, you are not allowed to define functions, yeah, that is named sine. Okay, square root. Okay, 3. Okay. All right, next, atoms. Okay, Adam's name begins with a small case letter, or okay, if it is a single quoted. So for example, ABC. Okay, that is an atom. Okay, and well, it is the same thing as a single quoted ABC. It is the same. Okay, so atoms are internalized strings. Okay, that means atoms. Okay, all atoms are stored in the symbol table. All right, so Okay, of course, you don't want your program to create too many atoms and to blow up the symbol table. And a good thing about atoms is no matter how long the atom is, it always takes constant time to compare for equality or disequality. And quote it. So atom, okay, you can single quote everything. Okay, so this one, okay, it is an atom. Okay. All right, a character is a special, okay, special atom that has only one character. So for example, A is a character. Okay, so you can say cha A. All right, it is a character, but this AB is not a character because it has two characters. Okay. And next, okay, so atomic values. Okay, an atomic value is an atom or a number. So atomic, for example, you can test if a value is atomic or not. Okay, so okay, this is atomic. Okay, ABC. Okay, it is atomic. Okay. All right, next, lists. A list. All right, is so A, B, C. Okay, you can create a list explicitly by listing the elements and put them in a pair of brackets. And you can also create a list using this built-in called a new list. So say I create a list of 3 elements. All right, then X. It is a list of 3 elements, and in the beginning, all the elements are unique variables. And you can also create a list, okay, by using this we call range. For example, 1 through 3. All right, so this is a 1 through 3, or you can use steps. A step. Okay, let's say 1 through 10 with step 2. Okay, you can also use the list comprehension. Okay, say list. Okay, it is X. Okay, this is element. X is, let's say, element. Okay, element is in this range and even. Okay, E is even. This is called a list comprehension. Okay, so you can specify the property, okay, of the elements. Okay, and there are a large number of built-ins lists. Okay, you can get the length. For example, X is A, B, C, and len X. Okay, you can just say not len. Okay, you have to say either print len. Okay, because len alone it is a function. It is not a predicate. Okay, and as I said before, every query must be a logic statement that is either true or false. Okay, so you can do something like this. Say L equals X. Okay, oops, sorry. And well, just be careful since a list in Picat is a singular linked list, and the size is not stored anywhere. So that means in order to compute the length of a list, the system has to count. All right, so it takes a linear time. Okay. And well, there are a larger number of built-ins. Okay, so for example, X. You can also use unification. Unification. So for example, X is, okay, let me change it to X. Let me change it to say H and tail equals X. And this is H tail. It is originally from Lisp. H is called a car and T is called the CUDA of the list. Yeah. So H is the first element and T is the rest of the list. Well, you can also do something like this. Okay, let's say H had 1, had 2, and the T. Okay, so this becomes, okay, the first element is H1, the second element is H2, and the rest of the list is T, tail. Okay, you can use the unification. Actually, this is very convenient. Okay, you can use this to construct the lists. Okay, let's say X is ABC and Y. What is Y? Okay, let's say Y is let's say something. Okay, let's do this. Okay, A is BC and A is A, and then I add X. The tail is X. Okay, then you can see Y is ABC. Okay, so you can use this cons. It is called cons, C-O-N-S, cons operator, okay, to extract elements from a list. And you can also use this, okay, to create a new list, okay, based on another list, another existing list. And you can also use functions to extract elements. Okay, so for example, X is ABC, and then let's say F is first, X, and this one last, X. You can also use this called slice operator. Okay, slice operator. Okay, so let's say X, let's say Y equals, let's make a little bit more interesting. This is X, okay, slice operator. Okay, this is, let's say, from the second to the third element. Okay. Well, this is called a slice operator. Okay, it takes variable X and then a range expression. You can also use the index operator to access elements of a list. So for example, this is E is equals X. Okay, let's say it's the second element. All right. Well, just be careful. The index, okay, indexes start from 1. So the first element has index 1, and the second one has index 2, and so on. Okay, so that's why, okay, the second element, okay, in the list of the list is big. All right, and concatenation. Okay, you can do concatenation. Oh, just be careful. This index operator, since a list is a linked list, and this index operator takes linear time, because in order to get the element of the given index, the system has to traverse a list, okay, starting from the beginning. So, all right, concatenation. Okay, let's say A, B, C, D, and Y is, okay, E, F. And you can say, let's say Z equals X plus Y. Okay, concatenate. All right, good. And there are a bunch of non-deterministic predicates on lists. Okay, the most famous one is called member. All right, you can do this. X is A, B, C. All right, let's say this is an element of X. Okay, so, well, the query is like X is a list, and element E is an element of X. So what is E? All right, and then the system will say, oh, A is an element of the list. And then, okay, B is an element of the list. And C is an element of the list. Anything else? Okay, then the system says no. Okay. And there is also append. Append is append A, B, C, D. Append, you can use append. Append is a very powerful predicate. You can use this to concatenate two lists. All right, so this, let's say EF. Okay, and then this append X, Y, Z. All right, and then this, okay, you can use this to concatenate two lists. And this is non-deterministic. Okay, so you can use this to search. All right, let's say X. Let's say X is ABC, and I want to say okay, let's say I want to say the first list. Okay, let's say prefix, and this is something element B. Okay, and what is the prefix? I want to concatenate this. This is like equation. Okay. So something comes before called pre, and then there is a list. Okay, the first element of the list is B, and then I concatenate this two and to make X. So what is pre? Okay, and then the system says, all right, the pre is A. Okay, actually, you can use this to search a list. And you can do something like this. Okay, pre, say post, and I concatenate pre and post to make X. Okay, X is no. Okay, so what is pre and what is post? Then the system says, oh, pre is empty list, post is ABC. Okay, you can find all the solutions, okay, to this equation. Okay. All right, good. That's list. And strings. All right, strings. A string is just a list of characters. Okay, so for example, you can say, okay, this is A, B, C. Okay, this is a list. Okay, list of characters. So say, okay, it is a string. Okay, it is a string. Yeah. Yeah. Well, just the difference between an atom and a string. An atom, as I said before, okay, is an internalized string. Okay, so it is stored in the symbol table, and a string is not. Okay, so that means in order to test if two strings are equal, okay, in the worst case, okay, it takes linear time. Okay, while it always takes constant time to test if two atoms are the same. All right, next, another compound term is called a structure. Okay, let's say we have this pointer, P, okay, is a pointer. And this pointer has a name. Okay, this pointer, okay, this is a two-dimensional pointer. All right, it is 100, okay, 200. And if you do this, okay, the system will interpret pointer as a function call. Okay, so in order to tell the system that it is a term, okay, not a function call, then you have to precede the term, okay, by this special symbol, okay, called a dollar symbol. Okay, then the system will say, oh, this is a term, okay, not a function call. Okay, so it is term. Okay, you can use use index operator to access the elements. Okay, so for example, E equals P. Okay, the first element. Okay, the first element is 100. Okay, well, and also arrays. Arrays are like lists. Okay, arrays are like lists. It is okay. You can create an array. Okay, this way by listing the elements and put them inside a pair of braces. It is an array. All right, so you can get the length x. All right, this is a big difference between an array and a list is that an array is stored in a contiguous block of memory. So it takes, and also the length is stored as an attribute in the object. So it takes constant time to get the length of an array. And you can also use index operator, say e equals x 2. And also this index operator, okay, it takes constant time. All right, next, maps. All right, so you can create a map, or you can also create an array by using the new array built in. So for example, x is new array, let's say 10. Okay, the dimension is 10. You can also create multiple dimensional arrays, say 2, 3, 4. Okay, the first dimension has size 2, the second dimension has size 3, and the third dimension has size 4. All right, so in the beginning, all the elements are unique variables. Okay, good. All right, maps. A map is basically a hash table. Okay, you can create a map using this new map. Okay, in the beginning, you can give it some pairs of keys and values. Okay, let's say A is associated with 1, B is associated with 2. Okay, good. So this is a map. And you can do this. Oh, by the way, you see, in Picat, each query is independent. All right, so the system does not store any values. Okay, that's why for example, you can get this. Okay, and then you cannot say what is m. Say for example, this one is a map. M is a map. Okay, but if you say M is a map, okay, the system says no. Why? Because each query is independent. And in this query, M is a free variable. Okay, of course, a free variable is not a map. All right, so we can add elements. Say put, okay, let's say C is associated with 3. Okay, and we can also use this get, all right, to get the value that is associated with the key. Okay, let's say E equals get value. Okay, all right, so E is, okay, 1 is associated with A. All right, let's say if you should do D, and the system will get an exception, okay, because the key does not exist. All right, so sometimes you want to avoid exceptions. Okay, so what do? You give it a default value. Okay, so say, oh, I want to retrieve the value that is associated with the key. If the key does not exist in the map, okay, then return me the default value. Okay, let's say return me the default value 4. Okay, and then you will get the default value. Okay, all right. Okay, maybe I should also mention about global maps. All right, these are maps you newly created. Global map. All right, so you can put the data in a global map. All right, so this one, in order to M, is called get global okay, get a global map. Okay, so this is a global map. It's pre-created. Okay, so you can use this one. Put, say A1. All right, good. But one thing is this global map. Okay, let's say you get global map. Okay, so the value is stored there permanently. Okay, you see. Okay, this time you get M. Okay, the value is stored there permanently. Okay, let's say you want to store some values across the queries. Then what you can do is you store the values in the global map. Then you, okay, it's like a global variables. Okay, it is always there. Okay. So let's say get. Okay, what is the value associated with A in the global map? All right. Oops. Oh, I have to do this and dot get. And also about this dot operator. Okay, this dot operator. Okay, it's just a syntax sugar. It looks like OOP language, but this is not OOP. This is just a syntax sugar. It means the same thing as get M and A. Okay, M is the first argument. All right, good. All right, last but not least. All right, so we can compile how to, let me show you how to compile and load programs and how to run programs. All right, so well, you could do this. You could do this CL. You can type some simple programs, CL, and then you can say my member. Okay, so this is member. Okay, my member X. All right, this is X. True. My member, I name it my member because, okay, member is a built-in. You cannot redefine it. Let's say tail. Okay, my member xt. And then you type in this one, type Control D. I'm using Sigwin. It is a Unix. All right. So on Windows, you need to type Control Z. I type Control D. That's the end of file. Okay. So the predicate is compiled and loaded. So now we can query my member. Let's say A. Okay. Let's say B. A B C. And then see. Oh, the system says no. Why? Oh, because there's a typo. I'm sorry. Okay, there's a typo. Okay, member. All right, let me redo it. All right, redo it. Okay, the first rule is fine. Okay, let me just copy it. And the second one is my member. My member. Okay, starts here. All right, let me try again. All right, this time it says it works. Okay. All right, now let me show you how to run programs. Okay, let me exit the Picat system. Okay, in order to exit, you could just say hot. Okay, and you can also type Control D. Control D. Okay, sorry, hot, and then the system exits. All right, there is a program called Fibonacci. Is this one? Okay, no, this one is not there. Okay, let me create. All right, let's say Fib. Good, Fib. Okay, we write the Fibonacci function. All right, just hello world. Let's just say hello world. All right, or it's named Fib, but let's say just print ln hello world. Good, that's it. All right, so let's see how to run this program. Fib, okay, hello. All right. Okay, one way to run it is okay. This is hello. One way to run it, okay, it has a main predicate. All right, you can just do this hello and okay, then hello world. Another way to do it, okay, is use this REPL environment. So you start it and then compile, load it, hello, okay, and then you type main. Good. Okay, good. And I hope you enjoyed the video. Okay, thank you for watching.